All right, so this is going on page 68 when we're done. So yesterday we solved logarithmic equations. Today we're going to solve exponential equations, and there are two different ways to do it. That's why there's two different sets of notes. We're going to start with 3-7. So this is when they have common bases, which we've basically already done a little bit, but not some of the more complicated equations, so we're just going to go back through a few of these. All right, so our steps. We rewrite the equation using common bases. Okay, maybe they already have them, like on 1 and 2, the bases e and e, 3 and 3. Here, these are not common bases, so we would have to rewrite them. Then we use the properties of exponents to simplify each side of the equation, if necessary. Then we use the one-to-one property. So there's a one-to-one property for exponentials also. If b to the x equals b to the y, then x equals y. Okay, so if they have the same base, then the x, whatever's up in the exponent has to be equivalent to each other. Okay, so let's start with, we're going to start with number 2. All right, so if you look at number 2, these have common bases. So e to the 4w minus 1 equals e to the 5 minus 2w. That is a w, right? Because up here looks like a blob. Okay. So since it has common bases, we use the one-to-one property, and we get that 4w minus 1 equals 5 minus 2w. The rest is basic algebra. I'm going to add 2w to both sides. I get 6w here. Add 1 to both sides. I get 6. W equals 1. That's that easy. Okay. All right, so when it doesn't have a common base, then we have to get 1. Well, I could simplify 9 down to 3. 9 is 3 squared, but that's not necessary. If I can use 9 as the common base, that'll just make everything easier. And I can, because 9 squared is 81. So that means that I get 9 to the 4y minus 26 equals 9 squared. You have to have a step that shows that you have common bases. It's not like you can just say, oh, I know that's 9 squared, so I can set this equal to 2, even though that would be a true statement that your process doesn't follow. Now that I have common bases, now I can use my one-to-one property. So I get 4y minus 26 equals 2. So 4y equals 28, and y equals 7. Once you use the one-to-one property, the rest is algebra. Very good? All right. Oh, I didn't even mean to do that one. Oh, well, that's fine. So that's why I need to look back at my notes. All right, let's jump to 5. All right, so I have 2 here, which means my common base most likely is going to be 2, and I can do 32 as 2 to some power. So this is 2 to the m minus 9 power equals 2. Okay, so 32 is 2 to what power? 5. So it's the 5th, but I have to multiply it by that m plus 3, and since that is 2 terms, I have to have parentheses there. Okay. So that means now that I have common bases, now I get m minus 9 equals, and I'm going to go ahead and distribute now and get 5m plus 15. Then I'm going to subtract m from both sides and get 4m over here. I'm going to subtract 15 from both sides and get negative 24. So m equals negative 6. Thank you. Any questions at all? All right. Let's look at number 6. So I got 343. Well, I don't know what 49 squared is off the top of my head, but I'm pretty sure it's not 343, so I'm thinking I can't use 49 as the common base. You with me on that? So 49, square root of 49 is what? 7. So 7 times 7 is 49. 49 times 7, 343. So that means this 343 I can change into 7 to the 3rd power, and then I have to multiply that by 2n minus 4 equals, and if I want this base to be 7, what is my exponent going to be? Negative 2. Okay, good. And then that's times n plus 4. Right, because remember that negative gets you the reciprocal. Okay, so now I have a common base. I can set the 2 arguments, or the 2 exponents equal to each other. I'm going to distribute while I do that. So I get 6n minus 12 equals negative 2n minus 8. That's 8n equals 4. N equals 1/2. Any questions on that? We good with that? All right. Let's flip this over. Okay, so we lost my fraction bars. It's just a mess. No matter what I do, if I move something, my fraction bars disappear. Okay, so I need to get common bases. On this particular one, I have lots of options. I can use 1/4 as a common base. I can use I got to check that first. 4 times 4 is 16. 16 times 4 is 64, so that's going to work. So I could use 1/4. I could make it into 1/2. I could use 4. I could use 2. Got lots of options here. Since they're both already fractions, I would say we just leave it and don't worry about negative exponents. Make sense? Also, I don't think there's any need to break this one down if I don't have to. So I think I would just leave it as 1/4. Does that make sense to you? All right, so then I have, that means, and remember these parentheses are important, otherwise the exponent just goes to the numerator. So this is 1/4 the 2x squared minus 6 power equals, so then this will be 1/4 to what power is 1 over 64? 3. 3, and then my parentheses would be 2x squared minus 5. So there's my step that shows my common bases. Then I can take out the exponents, and I'm going to get 2x squared minus 6 equals, and I'll distribute 6x squared minus 15. This is a quadratic, so I'm going to set it equal to 0. So 0 equals 4x squared minus 9. And then 0 equals 2x plus 3 times 2x minus 3. So x equals plus or minus 3/2. What questions you got? Okay. So let's look at number 9. Can my common base be 9? 9 times 9 is 81. 81 times 9 is not 243, right? So what would my common base have to be? 3. Okay, so we can use 3. I have 3. This would be to the negative 2p power equals 3. And then I got to figure that out. You done with your quiz, huh? What is it? 5, yes. It's 3 to the 5th times 2p plus 6. All right, so I have my common bases. I use the one-to-one property. Negative 2p equals 10p plus 30. The rest is algebra. So I'm going to get, wait, what did I do? Oh, yeah, I'm sorry. Negative 12p equals 30. So p is equal to negative 30 over 12, which reduces to what? Negative 5 over 2. What questions do you have? Okay. All right, so I need to look for a common base for number 10. Now, I know I could break 64 all the way down to 2 if I had to. I could also break 512 all the way down to 2 if I had to, but I'd rather not because then that just might make my exponents a little bit more complicated. Is 64 squared 512? No. Like, even if you don't know what it is, it's not 512, right? All right, so I know 8 squared is 64. So what's 64 times 8? 512, right? So what can we use as our common base? 8. Okay. Or I could use 1/8. I mean, one of these is going to have to flip, but I think 8 would probably make more sense. So I'm going to get 8 to the 3 times 2y squared power equals 8. And then this would be to the what? Negative 2. Good. times 3y plus 5y squared power. Common bases, use my 1-to-1 power. I'm going to get 6y squared equals negative 6y minus 10y squared. I have a quadratic, so I want to set it equal to 0. So this is going to give me 16y squared plus 6y equals 0. What do I do next? Factor. Okay, so this is not a difference of squares, right? And it's not a trinomial. I just factor out the GCF. What's the GCF? 2y. Good, so I get 2y. That leaves me with 8y plus 3 equals 0. So I get that 2y equals 0, so y equals 0. And I get 8y plus 3 equals 0. So y equals negative 3/8. So my answer is negative 3/8 and 0. Excuse me. We're not checking for extraneous solutions like we did yesterday. Why do you think we don't have to do that? What kind of equations are we solving? What are these called? Exponentials. And your exponential function, your parent function looks like this, right? Does it have a restricted domain? No. You only have to check for extraneous solutions when you have a restricted domain. Okay, so that's why we don't have to check today. All right, so let's look at number 11. We have got to isolate the exponential. So I have 1 over here and I have 2 over here. I've just had 1 on each one of those. But I'm multiplying 2 terms with the same base. When you do that, what is your rule for exponents? Add them. If you have x squared times x to the third, isn't that x to the fifth? That's because your rule is to add the exponents, right? The exact same thing is happening here, right? So I'm going to take these 2 exponents and I add them. So I get 5 to the c minus 1 plus 3c plus 2 power equals 5 to the 7c plus 16 power. Now I have same bases on both sides, single exponentials. I can use the 1-to-1 property. When I bring these down, I'm going to go ahead and combine. So this is going to give me 4c plus 1 equals 7c plus 16. So then I'll get 3c on the right-hand side, negative 15 over here. C equals negative 5. Okay. What questions do you have? We're good on that? Okay.